All right. So we're in chapter 3, right? So we're talking about the work, momentum, and energy. All right. All right. Oh, shit. All right. So, like I said, we're gonna work on some problem solving. Well, I said we were gonna do that on Friday, but we canceled Friday's class. So, all right. So today we're gonna do some problem solving in chapter 3. All right. And we say, let's see. All right. So it says an 8-kilogram bowling ball rolling at 2 meters per second. Bumps into a guard, rail, and stops. All right. All right. So A, we want to know what is the momentum before hitting the guardrail. B is what is the impact or the impulse. How much impulse? What is the impulse? What is the how much impulse acts on the ball? How much impulse acts on the ball? And C is how much impulse acts on the guardrail. All right. Everybody? So we have a problem-solving procedure, right? What's the problem-solving procedure? What's the first step in the problem-solving procedure? What is the problem? So what is the problem here? Finding the momentum. Okay? We need to find the momentum, right? Find momentum. What's the next step? No, not given, not just yet, right? But we need a time frame, right? We don't necessarily need to worry about that, all right? 3 is givens, right? So now we know what? What are the givens? Huh? Say it again. 8 kilograms is what? Mass. Mass is 8 kilograms. What else? I can't hear you. Speak up a little bit. 2 meters per second is what? What is it? 2 meters per second is what? Time? 2 meters per second? That's a speed.
I'll see you in a bit.
All right. So we skip. This is actually step 3, right? What's step 4? What's step 4? We can skip that. Equation. There we go. What's the equation? For momentum. That's what we're looking for, right? Momentum, P equals mass times velocity. That's it. Right? And 5, right? So we can just what? P, and then mass is in kilograms, 8 kilograms. We need to make sure we have the right units, right? And 2 meters per second, right? Momentum. Momentum is a unit of energy, right? So, or a unit of, I guess it's a unit of force, right? Well, no, not force. It's got to be energy, right? Because this is going to be kilogram. It's going to give you 16 what? Kilogram times meter over seconds. Kilogram times meter over second square is a Newton, right? Mass times acceleration. This is mass times velocity. So it's not quite a Newton, right? Not a Newton, not a force, but it's similar. Not a force though. All right, so 16 kilogram per kilogram mass per second. Okay. And the second question is what? So this is going to be what? 16 kilogram mass per second. That's the momentum. Momentum. All right? And we know momentum causes things to move, so it's a form of energy. Not a Newton, but it's a form of energy. Kilogram mass per second. All right. So impulse, right? That's B. All right. So this is A right here. That's A. Now B. Right? B. Step one. Impulse, right? You're looking for impulse. All right. Now, I do realize these videos are recorded and made available to you on campus. All right. So, just so you're aware of that. All right. So we can skip 2, move to 3. 3 is what? Givens, right? We got the same givens, right? Mass, 8 kilogram, velocity 2 meters per second, right? Now we skip to what? 4. What's the equation? Force times time is equal to what? It is. It is. It leads to the change. And so, yes, y'all are both right. You're just incomplete, right? Or you're not incomplete. You just only said 1/2 of it. All right? So, impulse can be looked at as the change in the momentum, right? So, remember this equation? We had what? Well, we can write it here for 4, right? Ft is equal to what? Delta mv. Right? So delta mv means what? What does delta mv mean? Change, right? So that means delta mv means what? Mass and v 1 minus what? Mass at v naught. Or if you want to do, or you want to change it to 1 and then what? 2. Just means the change in going from this speed to this speed. Right? So when the ball was going towards the guardrail, it had a speed and a momentum. Well, if it had a speed, then it had a momentum, right? Then it did what? Hit the guardrail and then did what? Stop. So what is its speed now? 0. So then I know my first speed was 2 meters per second. So what? I do what? 8 kg, right? Because that's what we're solving for this, right? We're looking at, because this is equal to what? Ft, which is also equal to what? Impulse. Everybody following that? You following it? Impulse, which is Ft, is equal to the change in the momentum. So this is what happened when the ball went from 2 meters per second to 0. So because this is the same mass, we can. I'm gonna write it just so I don't confuse anybody. I'm gonna just write it twice. All right. 8 kilograms. V2 is 2, right? We started out at 2 meters per second, right? And then minus what? 8 kilograms. 0 meters per second. So actually, the impulse is the same as the momentum, right? Because we came to a complete what? Stop. So Y'all wanna, I'll rewrite this. So this can be written as, and this is what I was gonna do. I was just gonna factor the 8 out, right? Because it's a common term. And then do what? 2 meters per second minus 0 meters per second. Everybody following what I did right there? Where that roll at? We got the roll going? Somebody get a roll going for me. All right. So I am keeping up with your attendance, y'all. So, like I say, I hope you, I think Raul said y'all can see the attendance on Canvas, right? You can see your attendance, so you know where you stand on attendance. So every day, y'all write your name down. I'm recording it. I didn't record Wednesday because I just got behind on some stuff, but I got it here. And I will enter it when I get a chance. All right, so that right there, so that's gonna equal what? 16 kilogram dot meter over seconds. So A and B are the same thing. All right. This is your impulse. All right, and it goes back to, all right, how about let's do this. Let's do this. Say this, impulse, pow, right? Okay. This is B right here. I didn't write it all right here. I'll say right C top of the board. All right, so this is B. Right? Now, what happens with C? How much impulse acts on the guardrail? So that's a question for y'all. So I got a ball, and it has a momentum. It's going towards the wall, kind of like me pushing on the wall, right? Remember how we talked about me pushing on the wall? And what's happening with me pushing on the wall? It's the same thing. So then what happens to the impulse that acts on the guardrail? What is it? Huh? What is it? What acts on the what acts on the wall? When I push on the wall, and I told y'all, I explained. Somebody explain to me what we talked about when I pushed on the wall. Tell me what we talked about. Okay. So then, what? The same force. The same. Well, it's not a force, so let's not, right? No, I get it. I said it too, right? So sometimes we get these things, a lot of stuff to keep in mind at once, right? It's not a force, but it's related to a force. It's an energy. But the same impulse that the ball puts on the guardrail does what? Puts it back on the ball. Otherwise, what would happen? It would go through the guardrail. The same way I was telling y'all with me putting my force up on the wall. If I put more force on the wall than the wall put back on me, then what would happen? I would go through the wall. Same way a car, if you a car going traveling towards something that's not strong enough to stop it, it's gonna do what? Go through it. Like a car running into a house, right? Especially a wooden house or something like that. It's gonna go through it because of momentum, conservation of energy, all of these things we're talking about. Okay? But yes, so the answer to C is the same. And why? What's the name of this law? Third law. Yes, Newton's third law. The same. The same impulse. All right, so I just put that, the same impulse, right? And then we probably what? Newton's third law. That's what we learned from chapter 2, right? That's what? F from 1 to 2 is equal to what? F from 2 to 1. Whatever force 1 puts on 2, 2 puts back the same force on 1. If I slap you, you're going to slap me back. Or I should expect you to slap me back. That's the law of the universe, right? Newton's third law. Okay? So you got to kind of keep all these things in your mind, right? When you're going through this stuff. Sometimes you're going to forget it, all right? But that's a point of practice, okay? All right, we're done with that. Let's go through one more. I think we probably have time for one more. And today is Monday. So on Wednesday, we're going to maybe do a couple more, and then we're going to wrap this up, and we're going to move to chapter 4. Okay? And I'm going to assign, oh yeah, today I'll probably put some problems on mastering for you. So be looking out today. And we're going to go on to chapter 4. When is the spring break? April 14th? Oh, we got plenty of time. Okay. I think it's VRCC. They out right now, right? Huh? Next week? Well, y'all don't know. All right. Yeah, so we want to at least cover like 6, 7 chapters, y'all. Okay? I'm supposed to do about 10, but I normally get through about 7. Alright, so yeah. So that was impulse and all of that stuff. That garbage. Let's see. Yeah, we just did that. Let's try something else. Let's try conservation problem. Yeah. I think this is... Yeah. Get one from the back. All right. Calculate. Conservation of energy. There we go. friend says that when twice as much work. Man. Let's see. This needs not good. There's no calculation. Let's see. Stop. Throw one snowball down. No, let's go back to the chapter. Okay, let's do this. All right, we can do that one. That should be it. That's gonna take us out what we got. Yeah. All right. Let's say, suppose a gliding cart. Suppose a gliding cart. With a mass of 0.5 kg bumps into and sticks to a stationary cart that has a mass of 1.5. Has a mass of 1.5 kg. If the speed of the gliding cart before impact is let's say 5 meters per second. How fast? How fast will the coupled carts? How fast will the coupled carts glide after collision? After collision. All right. All right, so what does this sound like? Out of all the topics we've covered so far, right? Keyword here is what? Collisions. Yes, indeed. Collisions. That's what we've covered. That's what we've been talking about, right? That's a topic in this chapter, collisions. Inelastic versus elastic collisions. All right? So what's the problem, right? Remember, we got to go through our problem-solving approach. What is the problem? What are we solving for? Oh, not impulse. Read the question. Read the question. Huh? Speed when? After the collision. And of what? Of the two carts connected. Okay? So we're looking for speed, or V, right? So we're going to call it V after collision, right? And we wanted it to be in probably meters per second, right? All right, so we skip 2, which is the time scale. We get to 3 and write givens. What's our givens? Mass of what? Huh? You can't see it? So we have 2 different masses, right? So we got to specify which one. So let's call mass 1, let's call it mass A. Now mass A is what? 0.5, right? 0.5 kg. You can't see from that far? Can somebody, can most people see? Can y'all see this? Okay. And mass B is what? 1.5 kilograms. So we got mass A and mass B. All right. And what else do we have? Huh? The impact? The speed of which car? Which is which one? A. See, I'm trying to tell you how this is how you have to be very specific and keep up with things and be organized. It makes life easier. Okay? So this is VA, right? Or let's say V before collision. Okay? We can say that. Or VA, and then we say before collision, right? Was 5 meters per second. What was VB before collision? 0. Because the problem said what? This car was doing what? Stationary. And so, now we're at step. So now we got all our givens, right? Now we're at step 4. The physics, right? Huh? Equation. Yep. Which equation? Normally when we're talking about before and after, we're talking about what? Conservation. Before and after an event. We're talking about how much did I have before, and then how much do I have after the event. Okay? So, what we're talking about here is conservation of momentum. And what is the equation for conservation of momentum? It is mass times velocity before collision equals what? mass times velocity after collision. That's it. That's simple. Right? So then let's set this up. Let's set it up. I don't want to write on that side because it's going to be... All right, hopefully y'all got this already. Okay, so let's set that up so you can see it. All right, so we're in step 5. Well, we at step 4 actually. So I'm gonna write it here. Okay, so we got mass and velocity before collision, right? Plus mass, not plus, equals mass and velocity after collision, okay? So mass and velocity before collision, we have mass of A, right? 0.5, right? Because this will be total mass now, right? Not just mass of one thing, right? It's mass of all masses. So this is mass A, right? Times what? Right? Times what? We're going to do the mass of B too. Yes. Right? It's total mass. That's what I said. Right? So before the collision, we still had the mass there. It was just doing what? Stationary. So we got mass of that, right? Times what? 5 meters per second. Plus what? So this is really what? Mass A mass A times what? Velocity of A. Plus what? Mass B times velocity of B. That's going to be what? Before the collision. So this is going to be what? 1.5 kg times what? 0. That's why it just goes away. 0. Okay? And that's going to be equal to what? Mass A plus mass B together, right? Because they did what after the collision? Stuck together. They stuck together after the collision. Times what? V, and this is going to be after collision, which is what we're looking for. This is what we're looking for right here. I wrote F. I got F. Speed, velocity after collision of both masses. Right? So then we can finish it. Oh well, I wrote here. Sorry about that. Let's just do this. All right. So this will be what? 0.5 kg plus 1.5 kg, and that'll be the speed after the collision. Right? So we can write this here. This would be velocity after collision. So my final answer is V after the collision is what? Mass A times VA plus mass B times VB. All of that over what? MA plus MB. Right? So that's this. That's what? That's basically 0.5 kg times 5 meters per second plus 1.5 kg times 0 meters per second. So that's just going to go away, right? And then what? 0.5 kg plus 1.5 kg. All right? And somebody tell me what that final answer is. $1.875. Close, not it though. No. Close. All right. So just like I said in the beginning, y'all. So I see a lot of folks that just hanging out, right? They just hanging out, and just showing up every day and going through the motions. That's cool. All right, but 1.25. Got that? Yep. 1.25 meters per second. So does that make sense? Why? Tell us why that makes sense. Huh? Right. True, but what else? Huh? It's gonna slow down because it ran into something and it gained more. What? Inertia. Who said inertia? Did I hear somebody say inertia? No, I ain't hear somebody. That was me and my imagination. But it's inertia, but mass. Somebody said mass. Yes. All right, but the lesson is that's Newton's first law. Is that the two, once it collided into the train, it gained more inertia. So it slowed down from 5 meters per second to 1.2 because it's bigger mass. All right? So, all right. So we're going to continue on Wednesday, and then we're going to move into chapter 4. All right? And yeah, like I say, and pay attention to mastering because I'm going to put some work up there for you.
I have a pen.